Well, we have discussed in the last video lecture that the local extrema occur only at points where the derivative is 0 or undefined. So, let's first define critical number. What is critical number? A number C in the domain of the function f is called critical number. Remember the C, the critical number which is ultimately should be in the domain of the function. If f prime C is 0 or f prime C is undefined. And this critical number is ultimately becomes the local extremum value, or that means local maximum or local minimum according to this Fermat's theorem. So, what the Fermat's theorem says that Fc is local extremum, then C must be a critical number of f. So, there is a relation between critical number and local extremum. So, the critical number ultimately becomes the local extremum. So, to find the local extremum, we need to calculate critical number of the function f, and that critical number must be in the domain of f. Let's take an example. Find the critical number of this. So, we first find the derivative. 6 common I take out and I equate to 0. Means I will only check this first condition, not this, because there is, for this you need denominator. So, I will check this condition, that means I will equate to 0 and I solve it. I get two answers, -1, 2 solutions. So, at x is equal to -1, f prime x is 0, therefore it is a critical number. At x is equal to 2, f prime x is equal to 0, therefore it is a critical number. So, there are two critical numbers and both are in the domain, because domain of this is all real numbers. And if you draw the graph of this, okay, so then you will see that the local maxima happens at x is equal to -1, local minima happens at x is equal to 2. That means there is a connection between critical number and the local extremum. So, here we have some examples. Find the critical number and the local extremum of this. So, I find the derivative of this, then this, I simplify this. Look at it, if I equate to 0, you get 2 equal to 0. So, there you won't get any value of x. So, therefore, I will, since there is a denominator, when the denominator is 0, then the function is not defined. So, therefore, I put a 3x plus 1 equal to 0. Then I will get x is equal to -3. So, when x is equal to -1 by 3, f prime x is undefined. So, therefore, x is equal to -1 by 3 is the critical number, and note that this is in the domain of here. So, remember here I have not used f prime x is equal to 0. Here I have used f prime x not defined. Similarly, in this case also, here fx is this, then f prime x is equal to 0, it gives me 0. So, here I have used f prime x is equal to 0. So, x is equal to 0 is the critical number. So, here I have not used f prime x not defined, but here I find the derivative of this, it is this, then I bring it down. So, 1 upon 3x to the power 2 by 3, then x is equal to 0 is critical number. In this case, I have used derivative undefined at x is equal to 0. Let's take this example where we are finding the critical number of a rational function, and if you see the domain of this, so since x plus 2 is in the denominator, I will equate to 0, will give me -2. So, x minus 2, x is equal to -2 is not in the domain of this, because for x is equal to -2, fx is not defined. So, remember that x minus 2 is not in the domain here. So, I use the quotient rule to find the derivative of this, I get this. So, here I can use both the rules. F prime x is equal to 0. So if I equate to 0, cross multiply 0, 2x into x plus 4 equal to 0, I will get two answers, x is equal to 0, x is equal to minus 4. So these are the two critical numbers. And check this 0 and minus 4 are in the domain. Yes, these are the two critical numbers. And I will now use f prime x is undefined. So for that x plus 2 should be 0. So that gives me x minus 2. But this x minus 2 is not in the domain, therefore it is not a critical number. So out of these three, only these two are critical number. This is not critical number because these two are in the domain of the function f. This is not in the domain of the function x, their fx, therefore it is not the what you call the critical number. So for a critical number, the number should be in the domain of the function. So note that very important theorem, f is continuous on the closed interval ab, then each absolute extremum of f occur at either endpoint ab or at the critical number. This is the rule. So in all, the method of finding the absolute extrema of a continuous function on a closed interval are these. Number one, find all the critical numbers. So use f prime x equal to 0 if there is no denominator, and if there is a denominator, use f prime x not defined also. Then at that critical number, find the value of the function. Then compute the value of the function at the end point, that is end point, which is the closed interval which is given to you at a and b. You have values at critical number and values at endpoints. Then compare all these values. The maximum, the largest value is known as absolute maximum. The smallest of these is known as absolute minimum. Let's take an example. Find the absolute extrema of this on this interval. So this is a, this is b. So what I will do, I will find the value at these endpoints. So f of minus 2, 1, f of 4 is 37. Then we have already calculated the critical point, which are what you call minus 1 and 2. So I will find the value at this and this. See, we have found it. So I have 4 values. So which is the maximum of this? 37. So this is the absolute maximum and it occurs at x is equal to 4. What is the minimum of this? Minus 15. So this minus 15 is the absolute minimum and it is occur at x is equal to 2. Similarly here, find the absolute of this on this interval. This is a, b. So I find at f of 0, it is 0, f of 4, it is this. Then I find the derivative of this. I simplify this. So since we have a denominator also, I will use both the condition. F of x is equal to 0 gives me 2 by 5. So this 2 by 5 is in the domain, is it? It is between 0 and 4, yes. And then I use the f prime x not defined. Okay. So when it is not defined, when the x is equal to 0. So x is equal to 0 is the critical point. But this x is equal to 0 is not in this domain. So therefore I will leave 0. So therefore only critical number is 2 by 5. So I will find f of 2 by 5 till z. So I will compare only 3 values. So I will leave this x is equal to 0, which is not part of the domain. So domain means it is open interval, right? So we have 3 values. So which is the minimum of this? Minimum of this is what? So we have a what you call, so absolute minimum is minus pi, right? So I will say minus f of 2 by 5 is the what you call absolute minimum and it's occur at 2 by pi, right? And the maximum absolute maximum occurs at 4, which is 11.3137. So same examples here. So here in the first set of question, that is 3 to 6, we are just finding critical number. Just find the critical number, that's it. And then check what local maxima, minimum, or neither. So that we will see that how we are going to do that. Find all the critical number by, so for all this one this, and then critical number, and then again you are finding these. And here find the absolute extrema. So this is what the example I gave you here. You see the fx is given and the interval is given. So here there is no intervals here. So this is what the absolute extrema. This is the local extrema here in these two. Okay. So for all these examples of this, we will do it in the live class, and almost all I have done here, and we will do more examples in the live class about these. And here are the answer for that. So what we have studied in this video lecture for week 8 in the first part, that we have studied what do you mean by absolute and minimum values of a function, what do you mean by absolute maxima and absolute minima, local maxima and local minima, and the most important is critical number. Okay, that's all for week 8, the first part of the what you call 8. Then we will continue more detail in the second part, that is week 8b. Thank you.